We chose nickel titanium or nitinol as our alloy. Nitinol was discovered at the Naval Ordnance Laboratory. Some applications of nitinol include eyeglass frames, F-14 fighter planes, and robotic actuators. Nitinol has some unique characteristics including superelasticity, shape memory over large deformations, and poor thermal conductivity. Nitinol is difficult to make because titanium is reactive and the composition must be controlled at 55% weight nickel. Vacuum arc remelting is used to form nitinol, but it is time-consuming and expensive. Nitinol is a metallic bond with freely floating electrons. This allows for a stronger material. At high temperatures, nitinol has a simple cubic structure, also known as an austenite structure. This is the parent stage. As nitinol is cooled, it goes through an instantaneous and reversible solid-state transformation called the martensitic transformation. During this transformation, the cubic structure is distorted by an interstitial carbon atom that doesn't have sufficient time to diffuse due to the rapid cooling of the material. This leads to areas of tension and compression wherein the unit cell transitions from a simple cubic system to a body-centered tetragonal system. Pressures of 69 to 138 megapascals and temperatures of -50 to 110 degrees Celsius are required to achieve this transformation, and there are 4 stages, starting in final austenite and martensite. Austenite to martensite is known as the thermal shape memory effect because the alloy reverts back to its original shape and austenite structure when heated. This explains nitinol's superelasticity. The martensite structure is referred to as the daughter stage. There are 2 eutectic points. One is a temperature of 942 degrees Celsius and 27 weight% nickel and involves a transformation from liquid to beta titanium and Ti2Ni. The other is at a temperature of 1118 degrees Celsius and 65% weight nickel and involves a transformation from liquid to TiNi and TiNi3. The microstructures of compounds directly under the eutectic point will form lamellae, in which beta titanium and Ti2Ni form in alternating stripe patterns. There is also a peritectic point at a temperature of 765 degrees Celsius and 6 weight% nickel, which involves a transformation from beta Ti to alpha Ti and Ti2Ni. Additionally, there are 2 congruent transformations, one at 1,310 degrees and 55 weight% nickel, and the other at 1,380 degrees and 77 weight% nickel. These transformations involve no change in composition.